In this module, we'll turn your EUDI Wallet architecture into concrete technology choices. You'll see how to compare open source libraries, SaaS platforms, and vendors across standards, security, compliance, and cost, and how to build solid evidence for procurement and proofs of concept. So far, you've built a full blueprint: regulations and business drivers, requirements, compliance controls, target architecture, protocol flows, and Azure operations. Now we shift from design to decisions. You'll translate that blueprint into practical criteria to compare open source components, libraries, managed services, and vendors. Vendor evaluation starts by turning earlier decisions into testable criteria. Take the architecture choices, compliance controls, protocol needs, and operational constraints you've already defined, and convert them into specific must-pass checks. Clearly separate non-negotiables from preferred features and future roadmap items. Then apply your build versus buy logic. Where does a vendor truly improve architecture fit, rather than just winning a feature comparison? In an EUDI Wallet onboarding journey, no single vendor does everything. Wallet ecosystem providers focus on keeping your app compatible with different wallets and SDKs. Verifier platforms run OIDC4 VP flows, collect presentations, and validate evidence. Trust and credential services ensure issuers are legitimate and credentials remain valid. Around that, KYC engines, consent management, orchestration, and API security tools handle risk decisions, user permissions, process coordination, and secure connectivity. When you evaluate an SSI or VC library, think in two dimensions: technical fit and operational readiness. On the technical side, confirm support for your required standards, credential formats, DID methods, and status mechanisms, and check that cryptography and validation pipelines match your trust model. On the operational side, assess project health, licensing, security posture, and community support. Then decide, is this suitable for a quick proof of concept or trustworthy enough for production, business-critical flows? The Verifier platform acts as the traffic controller of wallet-based onboarding. It receives OIDC4 VP presentation requests from the relying party, guides the wallet through the flow, then validates what comes back. Strong platforms go beyond parsing tokens. They verify issuers, signatures, and credential status, and apply policy to decide which attributes are acceptable. They also integrate cleanly with KYC, profile, and audit systems, while delivering smooth QR, deep link, and fallback experiences for users. When you don't control the citizen's wallet, your architecture has to assume variation. Start by understanding what each wallet ecosystem actually supports: credential formats, presentation patterns, selective disclosure, and how it interprets metadata. Then evaluate the issuer platform. Does it implement OIDC4 VCI, issuance authorization, binding to a subject, and lifecycle features like refresh and revocation? Finally, document all wallet assumptions as explicit constraints and interoperability risks. Digital onboarding doesn't just check credentials, it runs inside a wider control fabric. Trust services validate issuers, certificates, and revocation, so you don't accept fake or downgraded credentials. KYC and AML providers flag sanctions, PEPs, and suspicious patterns before accounts are opened. Consent and orchestration tools prove what the user agreed to and coordinate complex journeys. And API security enforces access, rate limits, and threat detection, keeping the whole platform safe at scale. Protocol support is where interoperability becomes real. You're checking whether a wallet can run OIDC4 VP presentations end-to-end, including secure authorization requests, nonce use, and replay protection. When issuance is in scope, verify OIDC4 VCI flows, credential offers, and proof of possession. Then examine which VC and VP formats, selective disclosure methods, and crypto algorithms are implemented. Finally, ask for evidence: conformance reports, interop testing, and a roadmap aligned with EIDAS 2.0. Interoperability isn't just does the protocol work, it's does every field land where it should. You need to confirm the platform understands your schemas, maps attributes correctly, and enforces claim and presentation rules, including selective disclosure. Next, verify it can discover and honor issuer metadata, algorithms, and trust anchors. Then test with real wallets, different credential types, languages, and handoff flows, and confirm all verified attributes end up normalized in your KYC data model. When a credential is presented, we don't just ask, is the signature valid? We ask, can I trust this issuer right now for this purpose? First, check whether the issuer appears in a current trust list and that its certificate chain is valid. Next, confirm status, not revoked, suspended, or expired. Then enforce policy, which issuers, credential types, and assurance levels you accept. Finally, record every decision as auditable evidence. Technical fit is only the starting point. You also need to know whether a vendor can legally and reliably run your workloads in production. Check where data lives, how long it's kept, who can access it, and whether contracts and sub-processors align with GDPR or similar laws. Then look for solid certifications, strong logging and evidence export, and realistic SLAs with clear incident response and 24/7 coverage for your critical services. Here we're stress testing tools against 4 layers: identity and access, data protection, privacy controls, and resilience with monitoring. Begin with who and what can access the system, then how keys, secrets, and encryption are managed. Layer on privacy by design, only necessary data, clear purposes, consent linkage, and retention controls. Finally, check uptime, backup, and failover paths, plus logging, alerting, patching, and incident response that align with your Module 6 threat model. This framework helps you turn a messy vendor debate into a structured decision. Start by defining criteria that span technical fit, compliance, operations, commercial value, and strategic alignment. Assign weights that reflect your priorities, then score each vendor and open source option using real evidence, not gut feel. Include cost over time, lock-in risk, data portability, roadmap strength, and support quality. The aim isn't perfection, but a transparent, repeatable way to justify a long-term choice. You now have a structured way to move from requirements to a short list of realistic components. You've seen what makes EUDI Wallet onboarding interoperable, secure, and operationally viable. In the next topic, we'll turn that short list into a concrete proof of concept and an implementation roadmap.